Somebody asked a question in the group. Let me check that question first before, because I'll add it to this training. What's going on? Okay. So a question was asked in a group about control loop, where he said he wants to know how bypass are being carried out to bypass an alarm, something like that. Can't find the question again. If anybody can see it, please, can you just screenshot it and send back to the group? I can't find the question again. Okay, this is it. Can you see it? Now the person said, during maintenance activities, we will bypass alarms, right? How to do that? So he's confused about this bypassing of alarm. And I think since we're talking about this year's operation, I think it's best we also just talk about this. Now he also wants to know about cascades, split range, and other control loops. We have to give a set points to act accordingly, how to perform these activities, and please explain. Okay, so I think we'll just add this at the end of this class, and then we'll just discuss on all these things you just talked about. So now let's commence with our chemical injection. Right, so from the image here, we can see that on one side of this image, we have a live plant, a fixed platform that is looking very nice. Everything is okay. And then on the other side, we have a plant that is undergoing a lot of attacks, chemical corrosive attacks. Okay, so you ask yourself, why is this happening, right? Now, during operation, like what you see here from the from this other image, personnel tends to carry out some maintenance, physical maintenance, and then internal maintenance also, to ensure that the plant has high integrity and also ensure that everything is working perfectly. But then if the plant is abandoned for just like 6 months to 1 year, you notice that a lot of corrosion will start taking place. That's because we have the rains, we have a lot of attacks on the iron already there, and then corrosion start taking place both internally and externally. But today we are not talking about the external corrosion, we are talking about the internal corrosion, right? So chemical injection system, it plays a critical preventive and performance enhancing role, right? It prevents and then also ensure that the plant performs, to its best in offshore oil and gas production facility. Now, like major process equipment, like we have this, your separation, your dehydration, and all the rest, chemical injection system works continuously in the background. So this one works at the background. Now, everybody might not be seeing what is going on. Like if you're working in a different department, you might not know what the process department are doing to ensure that the plant is working safely to protect. Okay, please, can we mute our voice, please?
Send me SMS to see a cardiologist. Okay. There was no time.
Okay, so as I was saying, now these chemical injection system, they work at the background to ensure that we protect the assets, we stabilize production, and also maintain flow assurance and ensure environmental compliance. Now, without effective chemical injection, offshore facilities will rapidly experience corrosion failures, just like the image you saw before on the other slide. Now, we have hydrate formation, scaling, fouling, emotion problems, and microbial growth, leading to production losses and safety risk. So without this chemical injection, these are all the problems we'll be facing. We are not just talking about corrosion alone. We are talking about hydrate formation. We are talking about scaling. We are talking about emotion problems, and then even microbial attack. Okay, so all these are things that chemical injection system are trying to prevent and also to enhance the operations. In offshore environments, chemical injection systems are especially important due to the fact that aggressive operating conditions are present because we have high pressure, high temperature, we have H2S, we have CO2, and then we have limited space also for maintenance. So we need to ensure that we don't get to where we need to start doing maintenance all the time. So we have high cost of unplanned shutdown. Okay, so during shutdown for offshore platforms, they spend a lot of money to carry out maintenance. So we need to prevent periodic shutdown. Let's say we can start shutting down every 5 years, or let's say 4 to 5 years to do maintenance, but not like every 3 months or 6 months you shut down to do maintenance. So we have to prevent that kind of scenario. Now, strict environmental and safety regulations are also there. Okay, so regulations are there to check your prevention plans in your facility, to check your dosing rate and all those things for you to prevent shutdown. So this is another image of the effect of corrosion. You can see all the equipments, the pumps are all corroded due to lack of maintenance. Now, to prevent corrosion or this form of attacks to happen, we have various methods of injection. Okay, so I'm going to talk about these various methods. Now, the first one is the corrosion inhibition. Second one is a sodium hypochlorite. I think we mentioned this during our other class. Then we have methanol and glycol. Now, methanol and glycol injection is for hydrate inhibition. We have scaling. We have scale inhibitor to prevent your dissolved salt from precipitating and forming bigger particles. We have asphaltene inhibitors. We know of asphaltene. They are those heavy components in your crude that they will just they are sticky. They are dark sticky, hydrocarbons that will settle down if it's not prevented, and then it will block your pipe. Then we also have a wax inhibitor, but I didn't talk about that. So wax is almost like your asphaltene, but they are long chain hydrocarbons. Meanwhile, asphaltene, they are hydrocarbons that contains sulfur, nitrogen, and other elements. So we also have the demulsifier injection system. So this one, like we'll be talking about this one for preventing water, that is separating water from your crude. Okay, so we're going to talk about this one after the other. So the first one is your corrosion inhibitor. So corrosion inhibitor, this control is one of the most critical chemical functions in offshore facility. Corrosion inhibitor system is mostly designed to protect your pipes, like your carbon steel pipes, and then your vessels. It also protects some of your vessels, like your deaerator, and then your injection water system, and your wellhead, especially at your wellhead, because at that region we have a high pressure there, right? I know we have different forms of corrosion, especially the erosion corrosion, where due to the high flow rate, it tends to weigh out the internals of the pipe. So we need something to prevent that. And then also at the downhole equipment. Now the inhibitor behaves like a paint or a shield. So what this means is that just like you paint the surface of your pipes, what the inhibitor do is to form a coating at the surface. It attaches itself to the surface of the internal of the pipe, and then it forms something like they call it thin protective film, which blocks your water your oxygen, and your CO2. Already the pipe inside is oxidized. So all it needs to do is just to attach itself to oxygen and then water, and then corrosion will start occurring. So the inhibitor tends to prevent that bond between the water and then the ion. Now, if you go to the market and you say you want to buy corrosion inhibitor, you need to specify the type you want. So we have the water-based corrosion inhibitor, we have the solvent-based corrosion inhibitor. So for the water-based, from the name, you are mixing your corrosion inhibitor and water, okay? And then based on specification, there is a percentage, a ratio of the mixing. I think water is about 7% to about 7.5%, depending on the experience and SOP of the company. So let's take, for example, you want to mix your corrosion inhibitor and then your water. Let's say 20 liters of corrosion inhibitor, and then I want to mix it with water. So 7% of 20 liters should be about that should be around 1.3. Okay, that's about 1.4 liters. So you mix 1.4 liters of water and then 20 liters of corrosion inhibitor, and then you put into your corrosion inhibitor system, you blend it, then you use your transfer pump to transfer, and then you send it to the various locations. As you can see from the drawing by my left-hand side, you have water inlet, and then we have the corrosion inhibitor inlet. So they go into this tank, and then it's being mixed. After the mixing, your transfer pump sends it to the transfer tank, and then from there another pump transfer it to the various location. Okay. So talking about corrosion, we need to know that there are various types of corrosion, right? So we have the uniform corrosion. Uniform corrosion mostly at the surface of the metal due to environmental conditions like your rains, your air that is already there. So it tends to corrode the pipe, uniformly, right? So that's your uniform corrosion. Then we have galvanic corrosion. So this is when we have two metals attached together that are having dissimilar properties, right? So just like attaching your carbon steel and your stainless steel together, that's the area where they are being joined together tends to form corrosion over time. We also have pitting corrosion. Pitting they are like small holes that form on the surface of the metal, and then gradually over time they start spreading and getting bigger. Okay, mostly when we have some debris settled down in a particular region, and due to the fact that they are there, the heat transfer of that area tends to be very, very low. So from there, pitting start occurring, and then it will start propagating and then expanding. Then we have the erosion. So like I mentioned, erosion is due to flow, right? So just like you have your soil erosion where water, tends to take away the soil, the same thing happen here. Due to flow that is going on, it tends to weigh out the surface of the metal. So something has to be there to prevent it from happening. We have other forms. We have other ones like the crevice corrosion. Crevice is when two metals are, lapping together like this. So the area of the lap is where that corrosion starts occurring due to the fact that oxygen and other forms of this will just go there, settle down, and then they start propagating to form your corrosion. We also have other ones like, when you insulate a pipe, inside the insulation too, corrosion occur. So corrosion inside insulation is also one of them. And then corrosion due to stress. Now, if there's any stress on a pipe, oxygen tends to attach to that area and then start corroding. So these are various corrosion, but I think what we are trying to prevent here is mainly pitting and also erosion. Erosion is one of the most critical one that has to be prevented, especially inside the pipe. Now, a region like where you have just after your wellhead, going down to, after your Christmas tree, going down to your choke manifold, your choke. So that choke area, there is a high pressure change there. So due to the pressure, corrosion usually happen in that area. So we need to send in corrosion inhibitor there to prevent that region. Okay, so after injection at various locations, the chemical tends to travel with it, right? So when you inject the corrosion inhibitor, it travels with it. Some of them sticks to the surface, some of them form protective layers and then move along with the fluid. Okay, by the time it gets to the separators, it is being separated. Although not all will be separated, some still follow along, but then separation occurs eventually. Some remain on the pipe walls. The system consists of two corrosion. So like we mentioned already from what we see here, we have two corrosion tanks. So one is the mixing, one is the transfer. Transfer pumps help you to transfer from the mixing tank to the transfer tank, and then you send it to your various locations like your vacuum generator and then your wellhead at the upstream part of the system. So the next is the sodium hypochlorite generation system. And also we've discussed about this. We would say this system is just like your disinfectant, right? So it tends to kill uh, any microbial activity along that region in the fluid or in the water. So this one is basically for water treatment. Okay, so it provides an on-site source of disinfectants for biofouling and microbial control in the seawater system. This eliminates dependence on bulk chemical deliveries and ensures continuous availability onshore. So seawater from the seawater lift pumps is routed to this generator. The water first passes through water softener, and then I think we've talked about all this where it goes to the electrolytes, and then from there we form your hypochlorite. So this from this you can see the reaction that occur between the sodium and then your water to form hypochlorite and then your sodium hydride. So this is the hypochlorite that is used to carry out the disinfectants. So this is the chemical we need here, and this is the reaction that actually takes place. So next is our methanol / glycol injection system. So you can either use methanol to prevent your hydrates, or you can use a glycol to do that. All right, so the methanol injection system is a critical flow assurance system used in offshore oil and gas production to prevent hydrate formation in wells, flow lines, and surface facilities. So hydrates, they are like ice-like crystalline solids formed when free water combines with light hydrocarbons such as methane, ethane, or propane under high pressure and low temperature conditions. And then these conditions are very common in offshore. So I think we've discussed this a lot of time, how these hydrates have been formed. Hydrates formation can restrict or completely block your flow lines, cause sudden pressure buildup, lead to equipment damage or well shut-in, result in major production losses and safety risk. So a perfect example is what you're seeing here. Now this is your hydrates inside the pipe. Now this does not occur once. It propagates gradually, it builds up gradually. And by the time it's building up, it will start reducing your flow rate, okay? Pressure will start dropping. That's when you know that there is a blockage on the line. So hydrate is one of those things that block your pipeline, okay? And this is a perfect example of that formation. So this is why we need to prevent this from happening. So now locations there, methanol or glycol is injected at the wellhead. So mainly we inject this at the wellhead of the choke valve. And this location is deliberate and critical. So the reason for injecting before the choke is that the choke causes a significant pressure drop, which leads to the Joule-Thomson cooling. This temperature reduction combines with high upstream pressure creates ideal condition for hydrate formation. Injecting upstream ensures the chemical is well mixed with the multiphase fluid before the pressure drop occurs. Now, early injection protects your choke valve, your downstream flow lines, and your production headers and separators. So methanol and glycol work by shifting the hydrate formation curve. So what this will do is that, let's take for example, if the if the line is, let's say the temperature of the line is around 40 degrees, right? And let's say if the temperature drops to 20 degrees, we'll start having crystals. Water will start forming due to high pressure and then low temperature. It will start forming crystal. By the time you add your methanol, it will freeze it, right? Just like anti-freezing. It will enable your lower the temperature at which the water is going to form that crystal. So it means instead of forming crystal at 20 degrees, it's going to form crystal at around 5 degrees. It will lower the temperature at which that crystal is meant to be formed. Now with this, it will help safeguard your pipeline as long as temperature does not come below that 5 degrees, right? So if your temperature is around 40, or let's say 40 is too much, around 30 degrees, and then your system is meant to start forming crystals by 20 degrees. Normally, by 20 degrees, start forming crystal. But if you introduce your methanol, it will now prevent it to crystallize at 20 degrees, or rather shifts the crystallization down to, let's say, 5 degrees. All right, so that is what it does. Now we have methanol, we have glycol. Now, which one do you prefer? For methanol, it acts faster. It has a high effectiveness. It is volatile and consumed with the flow. So by the time you inject it, it will go along with the flow. It's often used for short-term or emergency injection. Now, for glycol, it is less volatile, can be recovered and regenerated. So for this one, you might need a regeneration unit to regenerate your glycol, which is going to cause more expenses. It is commonly used for continuous or long-term hydrate control, right? So due to this, you can decide to use anyone, but going with the methanol, we also safeguard our plant, and then it will help spend less money for the operation. So why actual valves depend on flow composition and condition. Sorry, what was this? All right, so in terms of the flow rates, the injection rate is about 0.1 to 1.5 gallons per mm of gas. So this is talking about the amount of gas in the line. Now, for you to inject it, you need to confirm the amount of gas in the line, and then know the rate at which you inject your methanol. So the pressure is around 150 to 300 bar, and then your methanol purity should be around 99%. So in terms of glycol, the concentration is around 70 to 90 weights per meg. Now, injection rates are often adjusted dynamically via the DCS. So from the DCS, you can adjust your injection rates with regards to well flow rates, pressure and temperature trends, and then water cuts. Okay, so next is a scale inhibitor injection system. So for scale is more like these, they are like dissolved salts that they are going to crystallize in your pipe. So just more like what happens at your hydrate formation region, but this one is for scaling. So the scaling inhibitor system is a critical chemical injection system used in offshore oil and gas to prevent formation and deposition of mineral scales within the wells, flow lines, and separators, and downstream processing equipment. Now, mineral scales forms when incompatible formation water mixes, or when changes in pressure, temperature, and fluid composition causes dissolved salts to precipitate out of solution. So when we have incompatible water mixture, or when temperature changes, and then or fluid composition. So let's say we have a particular crude coming, and then we have a lighter crude that comes in. So due to the change in composition, we might have salt precipitating to form scales. So over time, the scaling will start propagating, and then you start blocking your pipe. So common scale types include your calcium carbonate, you have your barium sulfate, you have your strontium sulfate, and then you have your calcium sulfate. Now, once this is formed, scale deposits are extremely difficult to remove. and can severely restrict flow or damage your equipment. So this is an example of your scales inside the pipe. Now the chemical used for this is a phosphonate-based inhibitors for calcium carbonates and then calcium sulfates. And then we have polymer-based inhibitors. We have phosphonates polymer blends, sorry. Now this chemical will stop salt crystals from growing by interfering with nucleation. Hence, salt remain dissolved instead of forming deposits. Now these chemicals are selected based on formation water chemistry, produce water composition, temperature and pressure conditions, and then types of scales. So before you select any of these type of inhibitor, the lab guys need to carry out the analysis to confirm the water chemistry and then water composition. That's when you will know the type of inhibitor to buy. Now, scale inhibitors are effective at very low dosage. So it means you are going to be injecting a low amount of the inhibitor, usually injected continuously in parts per million ppm related to produce fluids. Okay, in terms of operation, for offshore facilities have limited access to maintenance and cleaning. Therefore, preventing scale formation is far more practical and cost-effective than removing. Continuous and reliable scale inhibitor injection ensures that long-term flow assurance, stable production rates, production of critical processing equipment, compliance with operational reliability, and then the scale inhibitor injection system is essential for preventing mineral scales due to pressure, temperature, and water chemistry changes. By continuously injecting your specialized inhibitors at the strategic upstream locations, offshore operators protect separators, the pipelines, valves, and downstream equipment, ensuring smooth and uninterrupted production operations. So we have the asphaltene. So like I mentioned, asphaltene are those heavy hydrocarbons that are mixed with nitrogen, sulfur, and they are very sticky, dark, and they tend to settle along the pipeline to block the pipe. So this asphaltene injection system is designed to prevent precipitation and deposition of asphaltene from crude oil during offshore production and processing. Asphaltene are heavy, they are complex hydrocarbons molecule naturally present in crude oil. So under certain operating conditions, asphaltene can separate from the oil phase and form solid or semi-solid deposits, leading to serious flow assurance problems. Asphaltene issues they are particularly common in high API gravity crude with unstable composition. So if you have high API gravity crude, let's say from 47 to 50, let's say 52, the asphaltene tend to separate easily to settle on the pipes. Now, fields experiencing pressure depletion and then system with significant pressure and temperature changes. All these are issues common with the asphaltene. Now, this is an example of what asphaltene is. As you can see, they are dark, they are very vicious, and then they can block your pipe you see, like the pipe here, it reduces the radius or internal diameter of the pipe. So with this, your flow rate is going to be very low, your pressure is also going to reduce. So asphaltene inhibitors are typically specialized organic chemicals. Commonly, your dispersants, your solubilizers, and polymeric inhibitors. These chemicals work by either keeping asphaltene dissolved in the crude oil or dispersing asphaltene particles to prevent agglomeration and deposition. So what it will do is it will help to keep them agglomerated. So it will not allow them to form that sticky part that will attach itself to the surface of the pipe, right? It will dissolve it, break the particles. It will just break down the particles of the asphaltene so that they will be able to dissolve and then flow easily with the pipe. So The selected chemicals depends on crude oil composition, asphaltene onset pressure, temperature profile of the production system, and then historic field behavior. So these are criteria for selecting the type of asphaltene inhibitor that you need to use for this system. So normally we need to carry out analysis from the lab to get these parameters. Now, asphaltene is commonly injected at the wellhead, then at the production manifold, and also at the first stage production separator. So you can inject them at these three locations. Now, their upstream injection is critical because the largest pressure drop occurs across the choke, right? So early gas breakout significantly affects crude stability. Downstream equipment must be protected. So if you look at our DCS simulator, you notice that all these inhibitors are located at this region. So this is for methanol. So methanol is added before the choke valve. And at the top, let's see what we have here. So here we have corrosion inhibitor here, and then asphaltene is at this other part. So these three of them are injected at the wellhead before the choke valve. So this is due to pressure drop that is resulted at this choke valve here. So the inhibitor travels with the crude oil through separators and downstream systems, providing continuous protection. Okay, so demulsifiers. So demulsifiers, these are also chemicals that they are used to break water in oil emulsion. They form during the crude oil production and then process. So while the crude oil and water and other particles are coming up from the well, due to the fact that the pressure, they are mixing and all the rest, the water tends to blend with the oil, and then by the time it comes up, separation, it forms this emulsion that it makes it difficult for you to separate oil and water, right? So you can separate most of the water, but some part of the water, they are emulsified in the oil. So in order for you to break that bond that was caused by high pressure and those agitation inside the pipes, we need an inhibitor to actually do that. And offshore facilities produce fluids often contain fine dispersed water droplets stabilized by natural surfactants such as asphaltene, resins, wax, and fine solids. These stable emulsions make oil water separation difficult and can significantly degrade separator performance. So demulsifier injection is therefore essential to improve oil water separation, to reduce water carryover in oil, enhance downstream crude dehydration, and produce water treatments. So for the demulsifiers, typically we have the non-ionic surfactants, we have the resin base or polymeric compounds, we have the blended formulation tailored to specific crude property. The exact formulation is selected based on your crude oil composition, based on your water cuts, based on the salinity and temperature, and then emulsion tightness and stability. So a lot of practicals still have to be done, to analysis still have to be done to carry out, to understand these properties so that we can select the right demulsifier. Now, the injection rates also, they are usually in ppm and optimized through laboratory bottle tests and then fine performance monitoring. So first of all, from the lab, the carry out tests to understand the rates at which you can blend these two products, both the crude and also the demulsifier, to know which one will give you the best solution. So the injection points for demulsifier is upstream of your separators, right? And also at the inlet of your crude dehydrator. So you can also add it there, sometimes directly into your well flow lines or your manifold for early contact. So I think it's good to start injecting it from the manifold so that by the time it travels down to the separator, it must have done the work of trying to break the oil-water bond. So early injection measures ensures that adequate mixing with the produced fluids, sufficient resident time for chemical reaction, improve separation efficiency in all downstream vessels. And then the demulsifier plays a critical role in your downstream system by reducing water contents, ensuring that crude exports entering your crude export pumps, lowering salt contents in your crude, improving electrostatic dehydration efficiency, and then reducing oil in water levels in produced water. So what this means is that, especially for your electrostatic dehydrator, if you if you inject your demulsifier, by the time you separate most of the water from your first stage, second stage, and third stage separator, it's going to help you, do lesser work at your electrostatic dehydrator, right? And then your water separation is going to be more efficient because you have lesser water there, and also the demulsifier has already done the work of breaking the bond. So it's just for the electrostatic grids to just carry out lesser work, and they will separate the water. Okay, so I think this is very fast. I thought we still have more. Okay, so I think we are done. We are done. So we just have some few assessment questions here. I will drop the PDF immediately after the class so that we can respond, because I think we are done for this session of our training. Okay, confirm you guys are still there.
Yes, I'm still here.
Yeah, we're here.
Okay, so I was talking very fast. I was thinking it's going to take more time. So, all right. So let's discuss any question from here. Anybody with any question?
Okay. Yeah, my name is Isaac. So, if you can hear me,
Yes,
I'd
we
like
can
to ask. I'd like to ask. Injecting all these inhibitors and all these chemicals, wouldn't they affect the quality of the crude oil and the price?
The quality of the crude oil and the price, right? Talking about the price?
Yes, I'm talking about
Yes.
injecting these inhibitors and all these other chemicals to prevent certain coagulation and problems in our pipelines. On the other hand, too, wouldn't it affect the quality of the crude oil when it gets to where we are going to sell it, or to the seller's place?
Okay, so
Yeah,
I think the effect that it can give is if we have a overdosing of these chemicals. If you overdose the chemicals, then it can give effects, especially if you did not separate them. Because, like, for some of the chemicals, by the time it gets to the separator, you can separate them at the first stage, second stage. They can be separated out from the crude. But then if you overdose it, that is when we have a problem. And also, most times, if you add in some chemicals, they tend to counter-react with each other and cancel out, right? So, which is why the lab is there to ensure that they test the crude before your injection, after your injection, at various locations to ensure that the quality of crude is not affected based on the dosage that is being injected. But overall, the system is being monitored to avoid those kind of effects, right? So if you overdose it, yeah, that's when it can give an effect.
Okay, thank you very much.
Welcome, sir. Okay, it's time for discussion. Let's go.
Yeah, I have a question on methanol and glycol.
Okay.
So, in which we have two chemicals, methanol and glycol, right? So, in which scenarios we use, like, what are the difference?
I think it's based on economic factors. I think, like I mentioned, let me go back. It's based on economic factors. One is more expensive. For glycol, you need to also carry out a regeneration, right? So you need to extract the glycol out and then regenerate it. So with that, you need to introduce more equipment. So it makes it more expensive for the company. And then that is a factor for you to select one. But let's go over. I said methanol is more faster. It acts faster, but then you inject it most times when there is emergency. That's when you use it. Okay, and then it is more volatile, meaning you can easily separate it. So methanol it looks more better to use, but the only problem is a little bit expensive. Now, for glycol, is less volatile. So meaning you need to separate it from the crude, right? And then to do that, you need to bring in more equipment for you to carry out that separation and then regeneration. So which is why you need to look for the one to select based on the economics of the company.
Okay, thank you.
Okay, sir.
Okay, okay, I have one question.
Okay, go for it.
Okay, this chemical injection, are they injecting it directly to the well or only within the process line? Is it down to the well?
From the wellhead.
To the reservoir.
From the wellhead.
Okay.
You see this one, the asphaltene is going to the wellhead, right?
Okay.
You can see the screen, right?
So which one is going to the process line?
For the process line, we have demulsifiers. Those ones are injected at the separators. You can inject those ones at the separators and then also at the dehydrators. But we have the methanol here injected at the shock valve. So this one is also at just after the wellhead, before the manifold. So you inject this one there. And also the corrosion inhibitor is also best injected before the shock valve.
Okay, so they have different places for injection.
Yes.
So the one that is going to the wellhead, if it is subsea wellhead, okay, where is the point for injection?
If you do what?
If it is subsea wellhead, how do you carry out this injection?
If you have two wellhead.
If it is subsea wellhead.
Okay, subsea wellhead.
Yes.
Subsea wellhead is still almost like your normal wellhead, so you still have a point for injection. There are various valves on your subsea wellhead. So there's a valve for connection of asphaltene on the wellhead.
Okay, there's a valve on the surface.
Yeah, there are various valves. Yes, there are various valves.
Yeah,
if you've seen the picture of a subsea wellhead, you notice that there are various nozzles where you can inject, attach your injection line to.
Okay, I got it. Thank you very much.
You're welcome, sir. Okay, so let's look at the question that was asked in the group. Let's look at control loop. Okay, so control loop. So I don't know if the person who asked that question is inside this class, so that we can. But it's talking about control loop, and it's very important that we understand. We have various types of control loop. So it's very important that we also know about this control loop, right? Now, we have shutdown valves, we have control valves, right? Now, this control valve here, the essence of this control valve is to control a particular parameter, right? So we have various parameters that we control. We have the temperature, we have pressure, we have flow rate, right? And then we have level. Okay. Now, if you look at this control valve here, it is tied down to a flow controller here, and then also tied down to a level transmitter. Okay, so it can either be working as just controlling the flow here, and then from flow we control the level, or we can have two controllers, one controller here controlling the level, and then another controller here controlling the flow rate. But we have just one control element, which is this control valve here. Okay, so the process or the mechanism of controlling these these various parameters is what we call your control loop. Okay, so you can either have a closed loop system or an open loop system. Okay, so a closed loop system is let's take a look at this control valve here. Now, if you open this control valve, right, you are increasing the flow rate. By the time you open the valve, the more you open the valve, the more the flow rate increases. Okay. Now, by the time you're opening the valve and the flow rate is increasing, the level of this vessel is going to be dropping, right? It's going to be dropping. So if you are opening the valve with respect to the level, controlling the level of the vessel, then that is a closed loop system, because you are trying to control by taking note of sending signal to this controller for the level, and then some calculations are done, like there's what they call the PID, I think proportional integral derivative. It does your calculation and try to ensure that you control the level. And this is when you're using auto mode or cascade mode, right? So it controls based on a particular set point. So that is closed loop. Now, if you're talking about the other one, which is open loop is when you just open your valve. You are not you don't care about the level. You just open the valve for the level for the flow to just continue. So that is when you're talking about this shutdown valve. Although shutdown valve is meant for a different scenario. When there is a critical issue, the shutdown valve is meant to just automatically close and open. But if you are using this shutdown valve for the instance of just opening the line, now if you open it, the level will just, without this control valve here, if you open this shutdown valve, the level will just start dropping because there will be flow. Now we are not minding if the level of the tank is going to go empty or not. It is just allowing flow to pass through. So that is an open loop system. Okay, so these are the various types of loops that we have. Now let's go over to the aspect where he said, if you want to bypass an alarm, right? Because we talked about alarm being one of the most critical aspects of a DCS operator by monitoring the alarms. We have high alarms, we have low alarms, we have sound alarms that make noise whenever there is something happening, right? So if you tend to bypass an alarm, like what he said, let me check again. What is the procedure, right? Okay, he said maintenance activity will be bypass alarm. During maintenance activities, we will bypass alarms, right? How do we do that? Okay, so as an operator, if you're a control room operator, and then this situation occur, what are you going to do? Now, let's say there is a particular vessel. Let's say this vessel now, the level is always going to high level, right? It's going to a high level. And then by the time it gets to the higher level, it will start making noise in your control room. It will start beeping and then making a lot of noise in your control room, right? You call your instrument guys, or let's say you call your field operators to go to the field and check out the level. And then they notice that from the level gauge, every vessel has a level gauge where they can physically or visually see the exact level of what we have in your vessel. Now, if they check from the level gauge, it's showing that we have, let's say, 50%, right? So it means the level is okay. But from your DCS, you notice that the level has gone up to the higher level, right? And maybe after a while, it will come down. Then after some time, it will go up. So it's going to be giving you wrong signals, right? You might be thinking that there's a problem. Meanwhile, actually in the field, everything is okay. So we need to settle that situation, right? So the question is, do you bypass the alarm, right? And what are the procedures to bypass the alarm? Now, the first instance, you can mute or shelve that particular alarm. Whenever the alarm rings, you just mute it, right? That is what you can do. But is that also okay? Or, okay, let's imagine that the transmitter at that particular region is bad, and then they need to order for a new one, right? So if it is something they can finish within a day, you can mute it, and then you unmute it again. But if it is something that is going to take a long time, let's say you want to order for the transmitter from abroad, and it will take, let's say, a month before you get the transmitter, and let's say every 1 hour that alarm is coming on. Do you mute it, or do you bypass it? Okay, so if it is something that will take for a long time, then I think bypassing it is going to be an option. But then, what do we do before you bypass it? That is the question. So if you're a control operator, you need to know that we don't just tell your instrument guys to go to the field and then bypass your transmitters, right? There are procedures, there are things you need to do before you carry out that bypassing, right? And then one of them is carrying out what they call management of change. It's very, very important. And that management of change is to safeguard you as a control operator, because you're going to be having your documents stating why you are carrying out that bypassing. Okay, the process guys, the safety guys, they are going to carry out an assessment, risk assessment, to ascertain if they bypass that particular alarm, what is going to be the effect, right? They are also going to look at modalities, safeguards, right? If they bypass that alarm, what are the safeguards you have in case actually the level rise up to the high alarm, right? Because what the transmitter is giving you is false alarm, but what if actually the level rise up to that high alarm, let's say about 90% and above? What's going to happen? What is going to safeguard the operation? What do you have? Do you have a PSV? Do you have let's say overflow line, a line that when the level gets to that, it will open a line and then send it to another vessel? Do you have it? What are the modalities, right? Do you send your field operator to stand at the level gauge to be checking a level every minute, right? So these are things you ask yourself, these are things you discuss, you document, right, before you accept for a bypass of a transmitter to be carried out, of an alarm to be carried out, okay? And then after they must have rectified that situation, they need to reverse back to the original state of that alarm, right? Because you don't need to bypass the alarm forever, right? Bypassing the alarm forever is going to cause, because at the long run, you guys will take that it's normal for the transmitter to be silenced, right? So with that, it's going to cause the situation later on. So bypassing an alarm is needed, is done, but then you need to carry out these activities before you allow for bypassing the alarm. I know most times bypassing it is not just removing the wire, right? Most times it is done by programming the DCS, right? So it means they have to call the DCS programmer to come around to actually program to put off that alarm. Then at the end of the day, they come back again to carry out your programming again to ensure that they activate the alarm back. So that is that about alarm. Now the next one is talking about controllers, right? Control loops. So we have manual control mode, we have cascade control mode, we have auto control mode, and then we have split range. Now these four are various ways where we control our operations, okay? So let's talk about manual mode now. Manual mode is used especially when you're starting up your plants, okay? So if you're just starting up your plants, you ensure that everything is in manual mode. You operate manually, and manually means that you're going to manually open and close the valve, right? So this control valve here, this is manual. For me to be opening this guy from 10%, 20%, 14%, 16%, this is manually, right? So I'm doing it manually. Now, let's say this flow rate now, let's say if this valve is 100% open, the flow rate is going to be, what do we have here? Let's say 2,000 kilogram per meter cube, right? 2,000. So it means if I reduce this valve to 50%, the flow rate here is supposed to be showing 1,000 kilogram per cubic meter. Okay, so with that knowledge, with that experience, you can be able to be adjusting your flow rate. And adjusting your flow rate means you are reducing the level here, either reducing or allowing it to increase. Because you know, from this vessel, we have our flow coming from your first stage separator. So since we have flow coming in, you need to adjust this control valve so that it balances the inlet and outlet of the vessel, right? So that you balance at a particular level. Let's say this is 19%. The level now is 19%. So let's say you want to balance this level at about 40 to 50%, right? So you open the valve manually to get to a particular flow rate, depending on the flow rate of the incoming fluid from your first stage separator. So you manually open and close the valve to control the level. Now that is manual, right? So you do this for all the other control valves. We have a control valve here at the top here, so you manually open this to operate. Now, if we move away from manual mode, the next mode is, let's say, auto mode. Auto mode is automatic mode. Automatic mode means, everything is advancing. Now, you don't need to allow your control operator to be stressed out all the time by, manually clicking all the valves. You come here, you click. We have a lot of screens that we have to go to, right? So you're adjusting this one. You come here, you adjust. You come to this other screen, you adjust. So you have a lot of screens and a lot of valves to control. Now, to reduce the stress from the DCS operator, we have a manual mode where you can put some of the control valves on, automatic mode, where you can put some of the control valves on auto mode, right? Auto mode means you have a set point, right? You have a set point that you want your level to be, right? Now, by the time you fix a set point, this is how it looks like. Now, for a real DCS, if you click your control valve, you're supposed to have a small page that will show like this. A small page will just show here. Here you have what you call measured variable, MV. You see MV here. Either measured variable or you see your set points, right? And then you have another place here. This is PV, process variable. And then you have values here. These values you have here are values from, this is your level here. So you have your set points here. And then here you have a button for manual mode, you have a button for auto mode, you have a button for cascade mode, right? So depending on the one you want to use, if you click on manual mode, then it will allow you to operate manually on this control valve. If you click on auto mode, then you can be able to allow the system, the PID, to automatically adjust the variables. So what it's going to be doing is, it's going to watch this value here. Now the measure variable or the set point is what you put. So let's say here is 3,000 something, 380 something. So let's say you want to maintain this level at, let's say 500 millimeter, right? You come here, you type in your 500 millimeter, because by the time you click on auto, it will allow you to type in something here. But if you click on manual mode, you cannot be able to type anything here, right? That is how it's programmed. So by the time you click on auto, you type in 500 here. So if you type in 500 here, the controller is going to be watching your measure variable that is being adjusted by your control valve, right? Now, control valve is going to be opening and closing by itself, adjusting so that we have this level, right? So by the time the value here gets to, let's say 520, or let's say 510, this valve is going to do what? This valve is going to open. It's going to open so that this level will come down to 500. Now, at a point to get to 400 and let's say 90, it will reduce to 490. Then what this valve will do is it will close. It will close gradually. This level will now go up. So it will just be going up and down, trying to form, I think there's something they call sinusoidal wave. And then until it gets to where the thing is now stable, right? It gets to where this valve will just be around 501 to 499.9, just like that. So you just be in a straight line, right? So that is auto mode. You are not doing anything at that point. You just type in something and then you enter, and then the system will just take over and it start controlling the system. Now, this can affect if the programming is not right? So which is why by the time they are doing commissioning of your DCS, they check all these parameters and confirm that the auto mode is working perfectly, right? So if not, if you are on real plant, you have to, even though you put it on auto mode, you still have to be monitoring what is going on, right? You go to the air screen, you come back, you check if the level is okay, right? So that is that for auto mode. Now we have split range. So split range, from the name split range, it means you are splitting your control. So for that system, you have, let's say we have a vessel, right? Now this vessel has temperature transmitter, a TT. Now this TT has a controller, a TIC, temperature indicator controller, right? Now this controller is now controlling two lines. We have one line for cold water. This is cold water. We have one line for hot water, right? Now you need to maintain this temperature at a particular temperature. Let's say 50 degrees. I want to maintain this water at 50 degrees, right? So this controller, we have one controller now controlling two variables, which is from this control valve and this control valve. That is what we call split range. So this is not really common in oil and gas, especially offshore, or even refineries. It's not really that common, but this is, I think it might be common in maybe all these petrochemical plants, but it's not common in refining or production. So understand the fact that for split range, you are splitting the control. So one of this control valve might be opening from 0 to 50%, while this other one will be opening from 50% to 100%. So just like that. If the water gets too cold, drops down to, let's say, 45 degrees, the hot water control valve is going to open to allow more hot fluid to enter, increase temperature to a particular level. If it's going too high, it will allow open more cold water to come in, just like that. So we try to split the control between two control valves. So that is your split range. So this is something that you need to know. Then I think the last one is a cascade. So cascade is almost like your auto mode, right? It works the same principle like your auto mode. But the only thing here is that we have two controllers controlling one control valve. So I think we have one of the controller called the master, while the other controller is called the slave, right? So one is called the master, the other one is called the slave. So the master controls the slave to control this control valve. Okay, so it's almost like auto mode 2, but then we have two controllers functioning to control one control valve. So this is just the difference between manual, cascade, auto, and then your split range. And I think this is exactly the question that this person tried to ask here. All right. So if there is anybody that has any input on this aspect, or you have any question?
Actually, I asked a question and I got more clarity on this subject.
Okay. You are the one asking the question, right?
Yeah, I asked a question. Now I got some more clarity on this subject. Yeah, thank you. Thank you for that.
Okay. You're welcome, sir. All right. So I think any other discussion, any other thing before we call it a day?
Please, is the cascade control and the split range, are they similar to ratio control? Which of them is similar to ratio control or batch control?
I think split range is similar to ratio control.
Ratio control, okay.
Yes.
Oh, okay. Okay, thank you very much.
You're welcome. Okay. Mr. Peter Omotui. Peter Omotui, you're welcome. How you doing?
Yes, sir. Good afternoon, sir.
Yeah, good afternoon.
Yes, sir.
I think you came a bit late.
Yes, I think few minutes past 3, almost 15 minutes thereabouts.
Oh, okay, okay.
Yes,
You're
sir.
welcome. Paul Uti,
Yes, sir.
Fidelis, Soji, we didn't see you guys when we are trying to do introduction at the early hours of the class. Anyway, you guys are welcome. I believe we understand the concept for
Yes,
today.
I'm at work. I'm at work. That's why I could
Oh,
not come on time.
no problem, sir. Welcome. Sorry for the stress. Okay, so officially we are done with our
Hello,
training.
Mr. Nati.
Yeah.
Okay, sorry, I want to find out this. You mentioned that after the first stage separation, second stage, and the third stage, and the gas could be used for, you can flare the gas or you can re-inject it into the reservoir. But I didn't understand the process of re-injection into the reservoir, how you can reject it. And also the and also you said the process, they produce water, whatever the water from that is separated. You say they can also reject that one into the reservoir for further this. So I don't know the process. I don't know.
I think for this you need to go back to the produced water treatment training. You see from here, from this the oiler, right? The water produced, comes to this is the oiler. All the water is being directed to this the oiler, and then from here the oil, any oil that is carried over with the water is going to be separated and then sent back to the oil water tank. Then from there it can be sent back to the separator again, to the third stage separator. But then the water will now go forward to the second the oiler. Here, any gas, any trapped gas again from here is sent to your flare. Now the water here is now pumped and then sent to your H2S stripper. Okay, so this is where you remove your hydrogen sulfide. So after removing that, we have chemicals here. Like I think we explained all this. So you just go back to the video and then you watch that video. Then we have the skim pile. We have skim pile here. We have settlement tank and all the rest. And then for water treatments, here, this is the one you inject back to the well. So before you inject the water to the well, you have to treat the water, right? So this is where you treat the water from the water treatment facility. It goes to the vacuum deaerator, and then we mentioned this sodium perchloride that is used as a disinfectant. So it comes back to this area to disinfect all the aquatic organisms, or all those marine organisms around this area before it sucks it back again to the line, and then the process continues. And then we have okay, so from here we have booster pumps here. So after the treatment, we have booster pumps, and then we have water injection pumps. So these water injection pumps increase the pressure to a very high pressure so that it can be pushed down to your well. And I said it that day that we have a particular well. We have a water well here. This is the water injection well. So the water from that pump is coming down to this well and then going down to where it's to the zone where it now pushes the oil to come out from the surface. So just go back to the videos and watch it, please. You get more clarity on that.
Okay, so you can't inject this water to the well that is producing crude.
You are not injecting it to the well. You are injecting it to a separate well that has been drilled specifically for water injection.
Okay.
Yeah, it is.
Or is it the same way? Is it
What?
the same way that they use for gas injection?
No. Gas injection is you are injecting it to the well, to the wellhead. That is
Okay.
gas lift. You are using your gas to lift out the crude. Let's say the crude now is too heavy and the hydrostatic pressure is too high that the crude cannot freely come out. You send in gas to make your crude more lighter, just like you are atomizing your crude so that the crude can, be lighter and then it can come out by itself. So that's gas lift. So for that, if you look at the well here, you see, look at the gas lift here. You see from here, you're seeing it. Are you seeing it?
Yes, I am.
Yeah, so yeah, this is the gas lift now. It enters here and then goes down into the well.
Okay.
Yes, but for water injection, you have a separate well. You can have as many wells. You can have like 2, 3, depending on the amount of wellheads you have in that region. And then also depending on the reservoir too. And the formation.
Okay.
Yeah.
Okay. So when you inject this water, then it will boost the production from the other well that is producing crude.
Exactly. What it does is it tends to push out the remaining oil inside the reservoir, to push it so that it goes to your perforation so that it can come out from the well. Because by the time you're extracting water from the reservoir, after a long time, you start having some voids, some space, right? And the pressure will start reducing. So for you to boost the pressure of the well, of the reservoir, you need to send in water inside to pressurize the reservoir, to fill in all those spaces that they've removed oil. So by the time you pressurize it, the oil there will now move down to the zone where it will now come out to the surface of the well.
So now for this gas lift, there's a pipe connected to this wellhead that you can actually open the valve, the valve, or I don't understand.
Yes. You see the valve. There are valves here that you open.
Yeah. Okay.
Yes, there are valves where you open. Now this process occurs when you notice that your well is declining. Okay, so instead of using a water injection, or you can even use both water and this at the same time. But if you notice that your well is your production is declining, you can start with using a gas lift, right, to support it, to support the lifts. And most times is when you're starting off, especially for reservoir that have high API crude, that they have thicker crudes, right? We have less gas. If you have a well that have less gas, more of crude, you need to use your gas to boost it up. So you send the gas down into the well, and then it boosts the production.
Okay. Thank you very much.
You're welcome, sir.
Sanati, you just explained to him that gas injection and water injection, they are both secondary recovery, but gas injection does not require an external well. But
yes,
water require an external well.
Exactly. So I think you understand the concept.
Yes, I understand. It's a different well.
All right, thank you. Okay, are we good to go?
Yes.
All right, so if you have any question, please just go to the WhatsApp group and drop your question, and we'll try to, if you don't understand any part of the training at all, just type your question and drop there. We'll talk about it. I might do a video and drop, or I will just...
Sir, to shed more light on the water injection, Now the other well you drill, when setting in your injection tubing, it will be at water zone. In the reservoir, we have the gas, the oil, and the water. So you will not set your water injection tubing on any of those, either gas or crude zone. You will set it at the water zone layer so that it will be able to boost the production of the crude oil. That's the aim. That's just what I want to explain. Thank you.
All right. Thank you for that addition. All right. So any other question, please drop it in the group.
Mr. Nati.
Yes, sir.
Okay, it's with respect to the assignment you've given us. What's the time frame for submission? Because I've been very, very busy with work, so I've not really done a lot of it. So
okay,
what's the time frame?
The time frame depends on when you want your certificate. Okay. If you want your certificate this weekend, You finish your assessment, 80% of it you submit, and then you can get your certificate by this weekend. If you want to get a certificate by next month, and then you can delay, but everything lies on you. But I would suggest that everybody should do it as soon as possible so that we can wrap up with everything.
So the ones who have submitted so far, completing the first session, how many percent have we covered?
That's 5 questions. If you did just for the first section, that's 5 questions. So you need more 3 questions from this second session to be able to get 80%.
Okay.
Yeah.
Nati, I did all my 5 assignments for the first set too.
Please, Engineer Nati.